All right, good morning, everyone. Hope you guys all had a nice break. I want to go over the calendar for the remaining weeks before winter break. So we're gonna go through another review sheet today. We'll do review worksheet 4. I would like for you guys to kind of work on your own for these. You can use your notes, but I do want to kind of walk through what our first steps will be. I know you haven't seen this in a week, so I want to kind of refresh your memory. But the quiz will be on Wednesday. I don't want to put the quiz tomorrow. I need to get an extra day to kind of come back from break mode. But tomorrow we are going to start our next set of notes. So we'll do curve sketching. These are all topics that you've seen already, just from a trig perspective now. So we'll do curve sketching tomorrow. After the quiz, we'll do mean value theorem, Rolle's theorem, and even some more curve sketching practice from Tuesday. And then we'll do trig related rates. We've seen related rates, but we haven't seen it from a trig perspective. And then we have one last set of derivative rules. This isn't hard, it's just a matter of memorizing the new rules and applying it. So, and then we'll have the rest of the week next week to prepare for our test. And our test will be like the Monday of that final week. Okay. After the test, I'm going to be just trying to grade. I'm not going to grade all the tests fully on that day. I'm just going to look for students who look for test grades that may need or may want recovery. So Tuesday it's a full school day, but really I'm just trying to get the test graded so that I can get those back to you in case you need to do recovery. So if I see that you don't need recovery, then I may just finish grading that later and just focus on the ones that do need to be graded that have priority. So by Tuesday, I will let you know if you have a grade lower than 75, so that you have that opportunity to do recovery. And then I guess you can take recovery any of the days between Wednesday and Friday. But the schedule is that it's first, second, third period for makeups for Wednesday, 4th, 5th, and 6th for Thursday, and then 7th period for Friday. But I'm flexible. You can, depending on your schedule, you can just come make it up anytime, any of those days. But again, those are just half days that last week. Okay. Any questions? Okay. This upcoming quiz is going to be no calculator. Okay, so we really need to make sure that we know our unit circle values, and we'll review that. The upcoming test, though, will be, you will get to use your calculators, but you do need to show all your steps. Like I said, you do not have a calculator. So we'll go through the graphing so that you guys can use that to your advantage too when we're doing curve sketching. Okay, so worksheet 4. Before I have you guys write down the rules, let me just go through what steps we will want to take for each of these problems here. So for number 1, we have the square root of tangent to the 5th power 7 minus pi x squared. We want to find the derivative, obviously, but what rule can you see yourself going through here? We want to rewrite it using parentheses, and what do we see out of this? Okay, I mean, power rule, yes, but the larger rule is chain rule, right? You have outside, inside portion, right? Okay. What about number 2 here? What can we see involved here? Quotient rule, okay. All right, number 3, y equals negative x cosecant of 3 minus pi x. What do you see there? Product rule, yeah, it's hiding, but x and cosecant 3 minus pi, those are two separate terms there. All right, cosecant is not standalone, right? Cosecant is any trig is always going to have a an expression that's inside that trig, so product rule. What do you see with number 4 here? Implicit, okay. How many dy dx's do we expect to pop up? 4, right? You have y, there's 1, 2, 3, 4 times when y shows up, so we're expecting 4 dy dx's. Now we don't know how many y's are going to be in our derivative, but we do know how many dy dx's will be in our derivative. Okay, what else do you see besides implicit? Product rule. Do you see that? Y cosine y, those are two separate terms there. Okay, number 5, if position of a particle is x sub t equals 3 cotangent of t, find acceleration. So to acceleration, what do we have to do to get there? Second derivative, that's right. So we start with position, and then we go to velocity, and then we go to acceleration, right? These are all one derivative down from each other. So to get from position to acceleration, we have to get down to the second derivative. And then you can just plug in power 4 into the acceleration, use your unit circle value to help you get it down to a number, right? Or down to a fractional answer. And then number 6, find the tangent line equation for our function. We got to find our order pair. We got to find our slope, then point slope form. But to find the derivative, there's a little bit of what going on here. Not product. I know it looks like product because you think that cotangent and 2x are different things, but there's actually the same function here. What else could be going on here? Chain rule, right? 2 bracket cubed cotangent of 2x. Okay, let me review through the derivative rules. I don't want you guys to write anything down, so I want you to try them on your own. But I haven't seen these rules in a while, so just take a look at these and don't write anything down. I like to have them in 2 columns here: sine, tangent, and secant. And then your C functions are all laid out alphabetically: COS, COT, CSC. All your C functions produces negative derivatives. 1 and 2 look similar to each other, right? They just involve each other. Sine is cosine, cosine is negative sine. Tangent and secant involve each other. Tangent is just secant squared. Secant is just secant u tangent u times u prime. If you can figure out that pattern, then you're going to follow the same pattern over here. Cotangent is just negative cosecant squared u times u prime, and cosecant is negative cosecant u cotangent u times u. So, all right, let's see if we can write these down from memory, and then I'll go over them again, and you guys can go through each of the problems. All right, try them.
Let's see how we did here. So really just looking for patterns, right? Because all your trig derivatives are just involving each other. You don't have to create anything new that you don't see on that's not part of the original 6 trig functions, right? So they just involve each other. So hopefully that makes it a little bit easier. Just have to figure out where the patterns, how to build that pattern to build those derivatives. Okay, try number 1, and I want to just kind of circle the room and see if we're on the right track. I'll go over each problem, but I want to see you guys start them on your own. Okay, so number 1, we want to rewrite that radical as bracket to the 5/2. And then you're just taking care of your chain rule, right? Your outside portion, you do power rule for that bracket to the 5/2. And then you do your trig derivative rule for that tangent parentheses on the inside. So outside derivative first, 5/2 parentheses to the, what's the new exponent? 3/2, yeah. And then we can take care of the inside portion, right? Tangent's derivative is secant squared u times u prime. So then secant squared u times u prime, right? Pi is just a number. There's no need for product rule inside that pi x squared. It's just negative 2 pi x. Where does secant come from? So tangent's derivative is secant squared u times u prime. So we just look at the rule above here. Tangent of u becomes secant squared u. Okay, try number two. You're just following the rules that we from above, right? These are just the trig derivative rules and just applying them. And then taking care of all the u primes that's involved. Right, negative cosecant squared.
Would it change, why would it change into 5x squared instead of 5x?
Oh, no, sorry. So we 5x to the fourth, right? I bet.
Aren't you taking the derivative of cotangent? Why would it be the derivative of cosecant? So you did negative cosecant squared. U times u squared.
Times u prime.
Yeah, u prime.
5x. That's interesting. Am I missing something here? So cotangent of u is negative cosecant squared u times u prime. So what you guys have?
I wrote my rule wrong.
Oh. Yeah, because thanks for checking my work here. The only thing I'm gonna ask you for cleanup is just push all the coefficients out in front and just leave the trig as the end portion. Everybody okay with number two? Okay, next up, number 3. Yeah. So negative x is one term. Cosecant of 3 minus pi is the second term, so. Yeah, those are separate, right? So those, any trig is never going to be standalone. It's all going to be a u inside that trig function. Yeah. Okay, product rule, right? And that prime g plus f g prime. Negative x becomes -1. We keep the g function back to f, which is negative x. And cosecant of u becomes negative cosecant u, cotangent u times u prime. For the second set of terms, I just collected all the negatives that are associated with that second term and pushed them out in front, along with the pi and the x, and left the trig to be last.
Plus 5x cosecant because the negative x will negative 5.
Yeah, so there's more than 2 though. There's this negative x, there's the negative from the cosecant, there's also the negative prime. So, and so with the 3 negatives, I'm keeping that negative in front.
Okay, next page.
We mentioned implicit and product rule. Right, the product rule is for that y cosine of y. Implicit is with all the y's. In the equation, we know that they will all eventually produce some variation of y dy dx. We know we can expect 4 of them to show up in our derivative line. Okay, so try those steps. F prime g plus f g prime. Y's derivative is 1. We need to make sure we attach dy dx. We are asking for y's derivative. G is cosine of y, back to f, which is y. Cosine of y becomes negative sine of y times y prime, or times dy dx. And on the right side, cosecant of y becomes negative cosecant u, cotangent u times u prime. Y becomes 1 dy dx. Then the fourth term becomes 8x, and 5 is a constant, no zero here. So that's the derivative line. The rest of it is just clean up. You're trying to add and subtract in a way where your dy dx terms can be grouped together on the same side. Usually I like to have them on the left side. And I can factor dy dx out, and then I can solve for dy dx.
When you move the 8x over, why wouldn't it be negative? Or did you changed all the other signs?
Right. So the 4x squared was already on the right side. So I didn't have to move it, so I didn't change the sign.
It have to be on the right?
It just has to be on the other side of the dy dx term, because it doesn't have a dy dx, so that's why it's on the other
Like
side.
instead of changing all the other signs, can't you just move it, make it a negative? Instead of moving all the others over?
Yes, you could. Yeah, so there's another version of this answer. It could be negative 8x over negative cosine y plus y sine y minus cosecant cotangent y minus 1. So your answer may not look exactly like this, but if this is the same thing as multiplying by the negative 1 above and below, then that's equivalent. That's fine. But the way I'm going to do the problems, I'm just always going to group the terms, the dy dx on the left side, but you can group it on the right side. That's fine. Okay, number 5. Position is given by x sub t. We want to find velocity first, and from velocity get to acceleration. Okay, try that.
Okay, so position is 3 cotangent of x. Cotangent's derivative is negative cosecant squared u times u prime. That u is just x, so u prime is just 1, so nothing will come out of that u prime. But I do need to make that negative. I do want to get it ready for my next derivative step, so I pulled that exponent out in preparation of my next derivative, which I am expecting chain rule here. So there's an outside portion, there's an inside portion. I gotta make sure I take turns with them. So I get negative 6 u to the negative 6 parentheses to the first power. And then cosecant becomes negative cosecant u cotangent u times u prime. Okay, from here we can think about our unit circle values. Cosecant of pi over 4. We know that pi over 4, our order pair is root 2 over 2, root 2 over 2. Cosecant is related to the y value. So we know the sine of pi over 4 is root 2 over 2. So the cosecant of pi over 4 would just be 2 over root 2. So that's how I got that value there. Make sure I square that resulting value. Cotangent is just x over y. So x over y, the x and y are the same values. So if I divide these by each other, I'm just going to get 1 in return. So get it down to 12. So when you get your answer, you cannot leave your answer in this form. You got to get it down to this. Okay, last one, try number 6. Tangent line equation. So you're going to find your order pair, find the derivative, from the derivative, find the slope, and then point slope form. So for number 6, to get it ready for the derivative, we know we're expecting chain rule here. Pull that 3 outside a set of brackets so we can clearly see the outside inside involved when building our derivative. Okay, once we apply chain rule and we find our derivative, then this is a matter of figuring out what the slope in the order pair is at pi over 6. So pi over 6, we can insert it into the original function. We can also insert it into the derivative and try to get a numeric value out of both of them so we can produce our tangent line equation. So here, if I'm inserting pi over 6 into my derivative, 2 times pi over 6 becomes 2 pi over 6, which is pi over 3. Same thing here, pi over 3. And then I can also insert pi over 6 into the original function. I also get pi over 3 here. So really, we just have to figure out what the trig values are, or the ratios are for cotangent of pi over 3, as well as cosecant of pi over 3. So we know that cotangent of pi over 3, well, pi over 3 has order pair of 1/2 and √3 over 2. So cotangent is just x over y. So x over y, if I divide x over y, I can do 2's cancel out. So 1 divided by √3. Cosecant of pi over 3. And then cosecant is involving that y value, but that's really sine. So if I flip sine, I get 2 over √3. And I just multiply that out. Get negative 16 over 3. Or you can leave it as negative 48 over 9. That's fine. And then we also need to find the order pair. So cotangent of pi over 3. Cotangent of pi over 3, that's just x over y. So 1 over √3. 1 over √3 cubed is just 3 √3 in the denominator. So there's my y value, there's my slope, and then point slope.
How many questions are in the quiz?
6.
It's like this. There will be an application one for the part full.
I'm sorry?
There will be an application from the part.
No, they'll just be like this. Find velocity, find acceleration, and evaluate the acceleration. Okay, so tomorrow we need to do a new set of notes, but I do have one more review worksheet for you. I'm gonna call it review worksheet 5. I'm gonna have for you guys to pick up tomorrow along with the key attached, but I'm not gonna have it. I'm not gonna go over it in class. It's just for you to as a last practice before you take your quiz on Wednesday. But I will have a morning review Wednesday morning going over worksheet 5 if you want to walk through worksheet 5 with me. So, but yeah, quiz is Wednesday. No calculator. Hopefully that gives you an extra day to get yourself comfortable with all these types of problems for the quiz. Okay, come get your phones.